Hey guys, alright, we're going to continue talking about solving systems of equations. We're going to look at other methods that you can do algebraically or with calculators to solve 2 by 2 and 3 by 3 systems. So one of them is Cramer's rule. And Cramer's rule comes from doing the elimination method. He kind of figured out, sometimes we try to make these meet at maybe 5 and negative 5 to cancel out for x, or positive 2 and negative 2 for y. So Cramer's rule guarantees that we always get these equal and opposite. And so this is just a system of doing that. Okay, so it does kind of involve matrices a little bit, sort of. So to use Cramer's rule for solving a 2 by 2 system, if we have a system of linear equations in this form, basically what we're going to do is we're going to take what's called the coefficient matrix. Oops, here we go. This is called the coefficient matrix of the left-hand side, and that means the numbers in front of x and y. And so if we wrote that out, it would just be the a and b, d, and e. So we kind of ignore the x's and y's in front of them, but we kind of have a column that involve our x's and a column for our y's. Okay, so this is called the coefficient matrix. Coefficient matrix. Okay, and the first thing we're going to calculate, there's something called the determinant that we use with Cramer's rule. So this is called the determinant. Okay, and the first thing we're going to calculate, basically if we do this, this is like a little process. If we do this 3 times, we'll get our solutions for x and y. And it's a pretty easy process. So what we're going to do is we're going to take, when we find the determinant, we use these vertical bars rather than these brackets around our matrices. So just like a vertical bar, if I can draw one straight enough. If you see just vertical bars, and they're not really brackets around a matrix like this, it means we're finding the determinant. So to find the determinant, we're going to do 2 things. We're going to multiply and subtract. Okay, and we start in the top left corner. So kind of like you're reading a book, top left corner. So we're going to start by taking our first diagonal, which is a and e, and we're going to multiply these together. So I'm going to get a times e. Okay, and then we're going to subtract the product of my other diagonal. So we're going to multiply d and b together and subtract it from the first one. Okay, and this is the determinant of my coefficient matrix, whatever this number turns out to be. Okay, and this will be some sort of number. So let's use our practice problem over here for now. So my coefficient matrix, my coefficients in front of x and y here would be 1 and 1. And for x and y in the second equation would be 5 and negative 2. Okay, there's my coefficient matrix. And if we find our determinant, 1, 5, 1, and negative 2. Gosh, that's pretty jammed together. Let's make that a little nicer. 1, 5, 1, negative 2. Okay, so we're going to find our determinant. Sometimes you'll abbreviate that DET. So we're going to start by multiplying my first diagonal. 1, remember start in the top left like a book. 1 times negative 2 is negative 2. Minus, which is just part of the formula, 5 times 1, which is 5. So negative 2 minus 5 more is negative 7. That is the determinant of my coefficient matrix. Okay, so this value we're going to use, and I said if you can do this process 3 times, and it's a pretty quick process once you get the hang of it, if you do this 3 times, we'll get straight to our answers. Okay, so here's how. When I need to solve for x, we're going to take the coefficient matrix here, ADBE. Okay, basically, well, this value, the determinant, goes in the bottom of my fraction. So I'm just going to write determinant, DET, down here. Jeez. DET, so determinant. So this number is going to go in the bottom of my fraction. So So similarly for my example over here, -7 is going to go in the bottom of this fraction I'm going to set up. Okay. To find the number that goes in the top, we're going to do one more determinant. And if we're solving for x, remember we said there's kind of an x column and a y column. If I'm solving for x, we're going to replace the x column. Instead of having a and d, we're going to replace them with these values over here. So in place of my x column, instead of a and d, we're going to write c and f, those numbers. And then the y column stays the same, b and e. And we do our determinant with this. Okay, so starting in the top left, you would do c times e, which would be ce, minus b times f, or f times b. And that's over my determinant. And this fraction gives me my answer for x. So let's try that with our example. Okay, so we're going to need to do one more determinant. And since we're solving for x, we're going to replace the x column. Remember, this is like our x's and y's. We're going to replace the x column. Instead of having 1 and 5, we're going to put in these numbers at the right, 3 and 8. So the y column stays the same, 1 and -2. And we just calculate our determinant. So start in the top left like a book. 3 times -2 is -6, minus 8 times 1, which is 8. -6 and -8 make -14 over -7. And that tells me my x coordinate is +2. Okay, so we found x. That wasn't too bad. I know it seems completely different, and you'd probably just maybe want to go with elimination or something here, and you can get the same answer. We're just introducing you to a new method. Okay, so obviously we still need our y coordinate. And yeah, you could go back and use substitution, but that's not really what Cramer's rule is about. So to find y, that denominator again is still our determinant. So in my example, -7 would still be in the bottom. That's the determinant from the coefficient matrix. Always goes in the bottom of both fractions. And as you probably suspect, if we're solving for y, we're going to replace the y column with c and f. So we're going to replace the y column. So the x column from the original, in this case, was a and d, the x column in the original. So a and d would stay the same. But instead of having b and e here, we're replacing them with c and f. We're replacing them in the y column. And again, if I do my determinant multiplying by my diagonals, I have a times f minus d times c over the determinant of my coefficient matrix. Okay, so let's do that with the example. So this time, we're going to replace the y values with 3 and 8. So on the right-hand side, we're going to replace these with 3 and 8 and keep the original x values. So we're keeping 1 and 5 from the original. And we'll do our determinant. Those little stars, by the way, I'm just marking to remember to start in the top left. You don't have to write those. 1 times 8 is 8. Minus 5 times 3 is 15 over -7. And I end up with -7 over -7, which is +1. And there's my solution, 2 and 1. Okay, so that might have been confusing. Let's do another example. Hopefully this will clear it up. So we're going to do the same thing with Cramer's rule. Okay, so let's start off with our coefficient matrix. So my coefficient matrix would be, so I don't have it selected, there we go, 3 and 1, so 3 and 1, and then 1 and 2. Okay. And the first thing we do with that is we want to find that determinant. So we multiply by our diagonals. Remember, start in the top left. 3 times 2 is 6, minus 1 times 1 is 1. And so my determinant is 5. So when I go to set up and solve for x, I'm going to put 5 in the bottom. And when I go to set up and solve for y, we'll have 5 in the bottom. Okay, so we just need to set up and solve these other two determinants. When we're solving for x, we're going to replace the x column. Remember, this is like x and y. We're going to replace the x column. So instead of 3 and 1, we're putting in these numbers at the right. So instead of 3 and 1, we're putting in the 2 and 6, and we keep the y column the same. So solving for x, replace the x column. Solving for y, replace the y column. Okay, so let's finish solving for x. I'll do my diagonal here. 2 times 2 is 4, minus 6 times 1 is 5. So we have 4, oops, sorry, 6 times 1 is not 5. 6 times 1 is 6. So we end up with 4 minus 6, which is negative 2 fifths. So we end up with negative 2 fifths for x. When I'm solving for y, we keep the original x column, so 3 and 1 stay the same, but our y's are going to get replaced with 2 and 6. So I'm multiplying here. 3 times 6 is 18, minus 1 times 2 is 2, and we end up getting 16 over 5. And there's my y-coordinate. So the solution to this system, which had some fractions, 2 fifths, negative 2 fifths, and positive 16 fifths, is our solution. That's my x, that's my y. And Cramer's is nice to deal with fractions too, because you'll never see a fraction until the very end here.